All right, I think we're in good shape. So I already have those notes here on my iPad, so I'll get those set up here ready to go for us. Okay, so a scatter plot today. Have you guys worked with scatter plots before? Does it sound familiar? Maybe a little bit? Okay, so a scatter plot basically just helps us compare two different types of data. Okay, when we compare two different types of data, we call that bivariate data. All right, so a scatter plot allows us to compare bivariate data. And what we're going to do is today, basically, we're just going to get started with our topic. We're going to start by just defining what a scatter plot is, and we're also going to look at some different data associations that you might see when you do your own scatter plots. Okay, and this information will be enough to get us for you guys to do the first assignment for tomorrow. Okay, so you'll be able to do the first assignment for the topic tomorrow and get it into tomorrow and get off to a good start in this topic. Okay, so in order for us to do that, we need to collect some data, and I thought you guys might be good resources to collect this data. So what I need from everybody today, in order for us to collect our data for the scatter plot, is I need to know a couple of pieces of information. I need to know what time you went to bed last night and how many hours of sleep you received. Okay? And we'll document everybody's information here in the table. And then we'll make those ordered pairs, those entries ordered pairs, and we'll plot them on our scatter plot. Okay? So that's what we're going to be doing. So I'm just going to go around the room, and we're going to fill in our table, and then we'll talk about how to get this plot made. All right? Sophia, I'll start with you. What time did you go to bed last night? Round to the nearest half hour. Okay, we're going to round everything to the nearest half hour. What time did you go to bed last night? Or what time did you fall asleep, I guess?
Like 10.
10:30. Okay. 10:30. And how many hours of sleep do you think you got? Like 7. So what time did you wake up about? You don't know? We'll go with 7 then. That's fine. Okay. All right. So there's our first entry. Maddox, 12:30. Okay. And how many hours of sleep do you think you got last night, Maddox? So you woke up at 7:30 this morning? Around that? Okay. Fair enough. Abram, what time? So I didn't hear you. I'm sorry. 4, 1. Okay. Well, that's a little bit better. That's okay. You woke up at 7 this morning? Okay. Not that 4 o'clock would surprise me because we did have some 4 a.m.s yesterday. Okay. It was more like they went to sleep. They just took a little siesta. All right. Perry, 10 o'clock last night. Okay. And how many hours of sleep do you think you received? About 8. So about 6 a.m. Okay. All right. Trevor, 9 o'clock last night. Okay. So 7 a.m. this morning. That's been pretty tired last night, huh? Wow. We're pretty tired last night, huh? Yeah. You need to change your hours, Perry, to 9. Okay. All right. Done. Blaze, midnight. Okay. And how many hours of sleep did you get? 8. Okay. And Adam, needs your data. 12 a.m. Okay. How many hours of sleep did you get? 7. Okay. Let's see. Last night it was closer for me to be, I'd say 11. And I was up this morning at 5, so I got 6 hours of sleep. Went to bed earlier last night, but I couldn't fall asleep. Okay, so we have data now. Okay, we have data that I can email your parents if I have to. No, I'm kidding. I won't do that. The ones that went to bed yesterday at 2, 3, you should have seen their eyes. They were like, "Well, you really gonna do that?" No, we're not gonna do that. Okay, it's your business. We're just need this for some data points. I'm not gonna expose your secret. Okay, that's between you and your family. Okay, but we are going to use this data to help us create our first scatter plot. Now, before we start plotting our points, you might notice something a little bit different on this graph than what we've been seeing in the past. On this graph, okay, notice I didn't title your axes like I usually do. Okay, I also didn't put in your scales like I usually do. All right, for your next assessment, you have to do this yourself. Okay, so for the next assessment, you have to title each axis. You have to give each you have to define each scale. Okay, on your x axis and your y axis. So we're going to practice that a little bit today, and you get some more practice opportunities to do that with your assignments and your review for your assessment and all that stuff. Okay. So let's talk about first of all. Let's just title the axes, and what's really beneficial with this table here is that the table has the titles for you. All you have to do is just transfer those over to the right axis. Okay. So our x-axis, we'll just write that. We'll just write time to bed, like so. Okay. And then for the y-axis, we'll just write hours of sleep. And then it's done. Okay. Now, what we need to figure out here is what would be a good scale for our x-axis. We need to cover times from 10 or 9 p.m. to 1 a.m. So what would be an appropriate scale to use for the x-axis? Now, it has to be a consistent scale, which means each mark has to be the same amount of distance, okay, as we go away along the way here. Okay, so what are you thinking here? Anybody have any ideas? Okay, well let's look at it a half hour and see what would happen. Okay, now here's another thing we can do if we have to. We don't have any data until 9 p.m. Right? So what I can do is I can make a break here, like so, by putting a swiggle there or a zigzag. That's a break, and that tells the viewer that there's no data between 0, which in this case is 12 noon, okay, and the first entry, which for our purposes would be 9 p.m. Okay. What that does is that it makes the picture that we're going to get a little more realistic and easier to analyze, because then there's not that big white space for that first set of 9 hours, okay, where there's going to be no data values, okay, and that allows us to do that. All right, so is everybody okay with that? All right, so let's just try Maddox here. Let's start Maddox's idea here and see if we have enough spots here to do all this. So 9, 9:30, 10, 10:30, 11, 11:30, 12, 12:30, 1. Oh, look at that, 1:30. It's going to work out just fine. If somebody went to bed at 2 a.m., we would have been in trouble. Are you sure anybody didn't go to bed at 2 a.m.? I wouldn't be surprised. You do?
I did, yes. 100%.
So which one's the correct one here, Maddox?
2 a.m. You can keep it. That's like my usual time. I stayed up extra late last night.
Well, okay. I'll tell you what. We have some data here. We're going to let this slide by this time. Okay? I appreciate your honesty. All right. So now we got to figure out a scale for the y-axis. Okay? So this is a turn and talk opportunity. So you're going to turn to your group mates in your group and talk and figure out what would be a good scale for the y-axis here. Okay? How many hours should each of these marks represent? on the y-axis. Okay. Are you sure? Did I skip one?
No, I mine didn't line up. I skipped 11.
Oh, okay. Yep, that would do it. You guys' graphs will be a little bit different. On the other ones, since we've had such a broader range of times, we had to do just hours on those. Okay, so your graph is actually going to be a little bit more accurate because your range of times is smaller. All right, so turn and talk for the next minute and discuss what kind of scale would be appropriate for the y-axis. Okay, go.
It's still, it's one off.
Let me switch back. Back up a little bit. 9, 9:30, 10, 10:30, 11, 11:30, 12, 12:30, 1. This way. That's the way you did it. That's apparently did it. Okay. No, that's fine. You just finishing the scale. That's all. Not yet. We got to get our scale for the y-axis first, and then yes, we'll just plot them in order pairs. All right. So, anybody want to volunteer what they were thinking in the group, please? Well, we're not going to do not the type of graph we're going to do. So we're just going to plot these as ordered pairs. Okay, they're not going to form a straight line. Okay. What I need to figure out is what should each one of these right here, each one of these levels in the y-axis represent? How many hours do they represent? They need to be consistent as we go up. Okay, so each one of these levels represents the same amount of time. Okay. Harry, what are you thinking? Actually, I think that might work pretty well. Okay, so if each one of these represents an hour, we probably we could all perform something pretty well. Do you understand what I'm saying, Liz? Yeah. Okay. So you could also, if you have enough room, and if you wanted to make another break, you could go by the half hour if you wanted to. Because what's our lowest value? 6. Yeah. So you could go. You could make it. You could go 6. You could start with 6 at the bottom and do 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, and that would work also for this graph. If you guys have a very small span, a range of data here, so it worked for that guess. Well, I think I'm going to go by the hour here. Okay, so we're going to go hour 1, 2 hours, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now all we have to do is plot these as ordered pairs. Okay. So the first one is 10:30 p.m. and 7 hours of sleep. So it put the order pair right there. Everybody see how I got that order pair? All right, go ahead and plot your other points. All right, I got the points. Go ahead and get them all plotted on there. Okay, so here's the deal. All right, we have our scatter plot. So all you have to do to construct a scatter plot is plot order pairs that you get from your bivariate data. Okay. What's a scatter plot compare? It compares the time that somebody went to bed in this class to the number of hours that they received. Okay, those are the two things we're comparing here. Okay. Okay, so here's the thing. After we get our scatter plot created, now we're going to look at see if there's any correlation in the data. So we're going to look at here see if there's any association between what time somebody went to bed and how many hours of sleep they received. Okay. And by doing so, what we are looking for is there a certain kind of association here with the data? So we're looking for two different things here, okay? I'm going to show you a chart, and we're going to go over some of these data associations. So if you look right here on your screen, this is on your next page of your notes, so it's right there in plain sight for you, okay? Here are some of the ways we can describe data association. We have two descriptors that you need to be able to tell me when I actually do this on an assessment. One descriptor is regards to the direction of the data. The other descriptor is in regards to the form of the data. Okay? Now, we're going to make this really, really simple. For the direction, you have two choices. Either the data follows a positive direction or it follows a negative direction. Okay, so look over here in this first example for me. Okay, right here. This is a positive direction because this data goes from lower left to upper right. Does that make sense? Just like a straight line does, what we've been talking about in the last topic. Okay, now, if the data also has the form that when completed, when you scatter plot them, the majority of your data points formulate what could be a straight line or have that kind of path, okay? Then we say that the data also has a linear association. Okay? Notice that in this first example here, these data values, they're not all on the same straight line, but they're all so close together that they look like they could be a linear relationship. Then we say that form is a linear relationship, okay? For the next one here, this is a negative linear correlation. Same idea with regards to linear, but the data goes in the other direction, from upper left to lower right. Okay. We can also have a non-linear correlation. That means that the graph is not a straight line. It is a what shape is this graph, everybody? In the third one. What shape is this right here? A curve. Yeah. Mm-hmm. I could also have it curved this way if I wanted to. All right. So again, you can have a negative nonlinear relation or correlation. That's what I just sketched here, or you can have a positive nonlinear correlation. All right. And finally, if you can't, when you're all finished here, you can't make any kind of determination on any kind of association with your data, then it's very possible, although rare, that your data might have no correlation. If it's truly scattered. That's how we get the idea of a scatter plot. Okay? So 5 options, okay, for you to describe your data association. You can describe it as a positive linear association, a positive nonlinear association, a negative linear association, a negative nonlinear association, or no association or correlation. Okay? So I want you guys to look back at your scatter plot here and determine for me if you can tell me if this data follows any kind of association. Now, the way we've set this up, it might be a little tricky. So if you're having a little difficulty identifying this, I'm going to show you one from yesterday. It might be a little bit clearer to see this. Okay? But right now, turn and talk with your group mates and see what you think about, does your data show any kind of correlation between the time somebody goes to bed and the number of hours of sleep they receive? Okay? Take a minute, turn and talk. Go. I'm going to roll the dice. Okay? 3 times. wants to make it my first question. I'm going to talk about direction and form. Okay. Okay. Adam, were you able to make any conclusions about the correlation of your data? Okay. So, can you explain that for me, please? What do you mean by that? Well, I understand that's what you're saying, but I'm not quite following that reasoning because everybody here is going to bed at different times. So I'm not quite sure why they're all going at the same time. You're talking about how many hours of sleep they receive? Okay, so can you tell that a little bit more then, please? So what? Everybody got how kind of sleep? How much sleep? From what to what? Okay, from 6 to 10. Okay. Any general idea about how our data is looking here? Can anybody kind of conclude something from our data? Generally, like maybe, for example, Blaze. Okay, so it kind of goes down, and then it goes up just a little bit, and then it goes down again. Now, you got to remember, this is not like a line graph, okay? You got to look at the data as a whole, okay? We're not going to connect these points to go to a line or anything like that. But here's kind of what I'm noticing. I'm noticing that as you start earlier at the bedtime, what is the number of hours sleep you get? The earlier you start, the what? You tend to get more hours of sleep the earlier you start, or less hours of sleep the earlier you start. What do you think on that one, guys? More or less? I hear one person saying more. The 9 p.m. person, about 10 hours of sleep. The 1 a.m. person, got 6 hours of sleep. Seems to me like the earlier you start, the more sleep you get. Agree or disagree? Okay. All right. Now, it might not necessarily look like this on this graph because our data is a little bit more contained than usual. So I'm going to show you a graph from yesterday, and we're going to talk about association a little bit more. Okay? So let me pull up a graph from yesterday real quickly here. I'll just pull up third periods from yesterday. All right, so here's third period's graph from yesterday. Okay? You can see, let's get that over just a little bit so you can see the data table also. See how everybody's data looks, even the people that went to bed in the wee hours of the morning. Okay? So here's the thing. Now, using the two descriptors, direction and form, okay, tell me about the association of this data. Is it more easy to see an association here on this graph than it is on the one that we did? Yeah. Okay. Now, they do measure the same thing. I don't want you guys to think that they don't. But this one may be a little bit more easier to decipher. Okay? So turn and talk to your group mates. Okay? Give me an idea about the direction and the form of this data. Okay? If you can conclude there is a direction and a form of this data. All right? Turn and talk for a minute, and then I'm going to roll the dice for 2 more people. Okay? Are your descriptors positive or negative for the direction, linear or nonlinear for the form? Okay. And remember, you're just considering the majority of the points. If there's one that doesn't follow any kind of pattern or associated data trend, then you can disregard it. We're just looking at an overall general picture. Okay? This is this one right here. I'm not going to reveal who that belongs to. Okay? That was just one of many yesterday. That was a little striking. All right, I'm going to roll the dice. That person's going to help me out, all right? Remember, I rolled your number last time. I'm going to keep that number, and I'm going to roll another number for somebody else. So, Trevor, would you think that the data has a positive or linear direction? Positive. I said positive. I meant positive or negative. Okay. Yeah, I would. I agree with that. How about you guys? Shows a negative direction. Sophia, how about a linear or nonlinear form? Sophia claims linear. What do you guys think? Okay. I think that we could make the argument for your graph as well. If we were to change our scales a little bit and maybe put the break in on the y-axis, since we had that big gap of space there, you might be able to see that a little bit more as well. Okay? So I'm going to go ahead and just transfer those answers from this graph over to our notes and kind of go with that same trend. Okay? So on problem 3, we're going to answer those two questions. Okay, so we're just going to write the data has a negative direction. And for the form, the data is linear. Okay? That's it. And I believe you'll be able to do your first assignment just knowing this information. Maybe some of the information underneath that too. We'll probably talk about that today. We'll probably discuss it in writing some answers down for problem 4 on Friday. Okay? You guys good? Okay, so a couple of other things we can talk about here real quick, and then we're going to pull up this for today. Okay? Sometimes we have some unique situations happen with our data. For example, if we see a group of data values close together, okay, we call that a cluster. And they can appear at certain points all on our entire scatter plot. Okay, so if you have 3 or 4 points that are kind of all in a little group of them by themselves or whatever, we call that a cluster. Okay. And gaps usually separate clusters. A gap's a space in your scatter plot where there's no data. Okay. So we're looking for those too sometimes. And then finally, if you have any individual points or individual order pairs that are kind of by their lonesome and don't fit the overall pattern, We call those outliers. Okay? So, for our purposes, an outlier would be a point here where I might have had gone to bed at, I don't know, 9:30, but I only got 2 hours of sleep. That's definitely an outlier, right? Doesn't fit our overall pattern, because our overall pattern is that the earlier you go to sleep, the more sleep you should get, and this goes against that. So are you okay with that? Okay. So what we're going to do on Thursday or Friday, I'm sorry, is we're going to officially go over some of the rules on how to identify clusters, gaps, outliers, and then we're going to start trying to do our next bit of this, which is where we're going to throw some algebra into the mix. Okay. We're going to fit a straight line on this graph called the line of fit. We're going to write the equation of it in slope-intercept form. We're going to use a little technology to help us out. Okay? And that's going to be what we do on Friday. So with that, we're going to call it quits for today, and then we'll pick it up again on Friday. Okay?